Hi everyone. So today let's solve the problem new roads, right? So this was asked in the Codeforces round 386 for the division 2, rated for the division 2. So I can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Yeah. So first, just give me a second here. 1 second. Yeah. Let me or let's see what the question states here. There are n cities. Yeah. There are n cities and no roads, right? So there are n number of cities and there are no roads actually. Yep. So we must build exactly n minus 1 roads. Yeah. For the n cities, we must this one build exactly n minus 1 roads so that every pair of cities is connected by one simple path. So that every pair of cities is connected by one simple path. That is forming a tree. Forming a tree. So this is based on basically graph on trees actually. Yeah. Um, graph with trees actually. We must build exactly n minus 1 roads so that every pair of cities is connected by one simple path, that is forming a tree, right? So we are given t, nothing but the maximum distance from the capital. We are given t. What is t here? T is nothing but the maximum distance. I'll just write here maximum distance from the capital actually. Yeah, maximum distance from the capital. Yeah, just remember this one. Yep. So we have been or we are given t, the maximum distance from the capital, nothing but the city one, and then array a of I. So along with the t, we are given array of I as well, right? This one a of I, array a of I basically. This is nothing but the number of cities at distance I. Number of cities at distance I, right? At distance I. So I'll just write here number of cities at the distance I. Yeah. So we must ensure exactly k cities are dead ends. We must ensure exactly k cities are dead ends, right? If it is impossible, we have to print -1, right? Otherwise, print the road connections. Yeah. So I'm just getting a call. Just give me a second here. Sorry, I got a call. So let's continue with the same. So we must ensure exactly k cities, right? And are the dead edges, right? Dead edges in the sense with a degree 1. Yeah, just remember we must ensure exactly k cities excluding the capital are dead dead ends, sorry, not dead edges, sorry, dead ends actually with a degree 1. If it is impossible, then we have to print -1. If it is impossible, then we have to print -1. This is also one of the criteria that we have to remember. Otherwise, we have to print the road construction, right? Otherwise, we have to print the road construction. Just remember this one. Yeah. So this is what we have to do. So let me read out the question loud. Just listen to this carefully. This is important. So there are n cities and no roads initially. Yeah. So we must build exactly n minus 1 roads so that every pair of cities. So we'll be given pair of cities between this one distance between the one city and another city, right? So we have to build the road. We must build exactly n minus 1 road so that every pair of cities is connected by one simple path, exactly one simple path, right? So basically forming a tree, right? So this is the graph with tree question. Yeah. So we are given t. T is nothing but the maximum distance from the capital, nothing but the city 1. City 1 is considered as the capital, and then array ai, and then array ai. So in the input we should be having n, nothing but the number of this one inputs. Along with it, we should be having t as well as the array a. Array a. These three things we should be having accordingly with the question that they have mentioned. Let's discuss about the input output later. Let's move on with the further things. We are given t, the maximum distance from the capital, nothing but the city 1, and an array ai, number of cities at the distance I. So we must ensure exactly k cities excluding the capital I'm speaking of are dead ends, nothing but the nothing but with the degree 1. If it is impossible, then we have to print -1. Otherwise, we have to print the road connections. Otherwise, we have to print the road sorry, not connections. Yeah, connections actually. It's not the road construction. So did I write construction here at that point of time? Sorry, man. So we have to display the road connection, not the construction. Anyways, road connections. Construction has nothing to do with the connection. Sorry. Yeah. Otherwise, we have to print the road connections. Yeah. This is fine. So let me delete this one entirely. Now let's do one thing. Yep. We have the idea on the question. So let me scroll down here. Just give me a second. Let's discuss the input output part as well. So here you can clearly see, man. So this is nothing but the n. So this is nothing but the t. So this is nothing but this one. What do we call? N we have been given 7. So this is n. Yeah. And this one t we have been given 3. So this is nothing but the t. And this is nothing but the k actually. K we have been given 3. So this is nothing but the array A. So this is nothing but the number A. Sorry, array A actually 231. The elements within the array is 231. Yeah. So we have been given ntk accordingly with the question that we discussed, and this is nothing but the array A, right? So we must ensure exactly k cities are dead ends with the degree 1 along with the edges that we have to display here 713, right? So this is fine, man. So let's do one thing. Now we have the idea on the question as well as the input output part. So let's discuss the approach followed by the complexities and then let's write the code. Yeah. So now let's consider the same example, man. We have been given n7, k3 and t3 as well as the k3 and the array that consists of the elements 231. Yeah. So let's go with the distance 1 here. I'll just show you in a very simple way and let me explain the other things while writing the code. So distance 1 here. So we T and K we have been given 3, right? So also we have a array 2, 3, 1, right? So we have to go with the 3 distances here. Distance 1, distance 2, distance 3. So let me consider distance 1, distance 2 as well as the distance 3 here. So this is fine. For the distance 1, so we have to go with 2 cities connected to the capital 1. See here in the array we have 2 elements first, right? So distance 1, 2 cities, this one connected to the capital 1, connected to the capital 1. For the distance to 3 cities connected to the level 1 cities. 3 cities connected to the level 1 cities, right? So this one 3 cities connected to the level 1. So not the capital 1, it's level 1. Now for the at the this one for the distance 3, one city is connected. One city is connected actually to the level 2 cities, to the level 2 cities, right? So one city is connected to the level 2 cities. Yeah. So this is for the distance 1, 2, and 3 respectively. Now what we have to do, we must adjust connections so exactly 3 cities become leaves here. We must adjust connections so exactly 3 cities excluding one become leaves actually. Just remember this one. Just listen to this carefully again. We must adjust connections so exactly 3 cities become leaves actually, become leaves actually. Yeah. Yep. So we must adjust connections again. So exactly 3 cities excluding city 1 because that is the capital. City 1 is nothing but the capital. We have to exclude that one accordingly with the question that they have mentioned, right? So they have clearly mentioned in the question that one. So we must adjust connection. So exactly 3 cities excluding city 1 becomes leaves actually. We will track possible leaf counts per leaf, nothing but let's consider this one as b of I for now and adjust them to reach exactly k. Adjust them to reach exactly k actually. K nothing but 3 actually. Yeah. Finally, what we do, we connect the cities level by level, ensuring proper parent-child balance, printing each connection. Finally, what we do, we connect cities level by level, ensuring proper parent-child balance, printing each connection. So this is the idea. So this is the approach that we will be going with. Yeah. So now I hope the approach part is completely clear. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. Yeah, let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big of n and the space complexity would lead to big of n as well. So the time complexity here is big of n because we'll be going with a single pass for the construction as well as the output. Construction as well as the output. Yeah. So overall time complexity would lead to big of n. And what would be the space complexity here? Space complexity would lead to big of n as well. So because we'll be going with the array A as discussed in the approach and also B because we have to store per level data, right? So we'll be going with a B, right? Array B actually. Yeah. So overall time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively. Yeah. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. And one more thing before writing the code, so we will be going with a level-wise tree construction here. Approach, the approach name, we can just call this one level-wise tree construction, level-wise tree construction approach, right? So let's start writing the code now. Yep. So let me delete this one. So first thing here, we'll be making use of the fast input and the output. So let me import input output package. Yeah. So this is fine. Next, we'll be making use of the different utilities. So let me go with util dot star. So this is fine. So the next thing would be, let's go with a class main here. Uh, So main method, so you can just go with any class name that's relevant to the question. I'll just go with a main. So before going with the main method, so let's initialize certain things, right? So let's go with the maximum possible cities just for the this one, say for a size. So I'll just go with here static final. Let me go with n equals n followed by the four zeros here. 1 second. This one, yeah, accordingly with the constraint, let's consider this one. Yeah, so this one is three zeros, I have considered four zeros and a six. So this is fine. This is nothing but the maximum possible cities, right? Now let's consider, or let's initialize n, m and k. N is nothing but the cities, m is nothing but the distance plus one, m is nothing but the distance plus one, and k is nothing but the required dead ends actually. I'll just go with the static here. So this one will be int n comma m comma k. So this is fine. The next one is static here. So this one will be int. So this one will be a equals new int of n. This is fine. B equals new int of n. Yep. Now let's do one thing. Let's go with the total current dead end count. Nothing but I'll just go with static here int dot. Yeah. So yep. Now let's move on with the main method. Initialization part is complete. Let's move on with the main method. Also, let me include mm, throws exception. Yeah. So let's continue with the this one code actually. Let me paste this one. This is purely related to the input output. See, so this is nothing but the buffered reader for the fast input, print writer for the fast output, string tokenizer. So this one we have to read ntk, right? So this one, the first line ntk we have to read. For that one, we will be making use of the string tokenizer. So this is for the parsing. So this is integer type, right? So we have to parse int basically. Parse actually we have to pass. So we have made use of the integer dot parse int. This is fine for the nmk. And then finally we are incrementing the incrementing m for the easier one based indexing of the levels, right? So we will be going with a one based indexing. So I have incremented here. So here also I have said m is nothing but the distance plus one, right, for the one based indexing. So that is the reason we are incrementing here. This is fine. Next, this nothing but string tokenizer. We have to read the array from a this one, a of 2 to m, representing number of cities per level. We know this one, right? So that's what we have done here, purely related to the input output. Now let's move on with the logical part, man. Let's move on with the logical part. So we have to calculate the initial dead end candidates, right? So let me go with the total. So TOT variable that we have considered. So let me assign this one to the A of M. Let me assign this one to the A of M. So this is nothing but the last level cities are all leaves initially, right? So now let's move on with the iteration part. As usual, we have to start from 2, I believe. I less than M. Let me go with the plus I. Yep, so this is fine. So within the for loop, so let's go with the difference that gives the number of extra leaves, right? That gives the number of extra leaves at this one. What do we call? Mm, at the level 1 actually. Yeah. So I can just write it in this way. A and B are the variables we have considered, right? So this one will be B of I, that is equal to math dot max of what we have to pass here. One is 0 and another one is the current element A of I minus the next element minus A of I plus 1. Yep. Now this is fine, I believe. Simple. Now what we need to do, we have to add this one to the total leaf count. Nothing but here we have considered the TOT, this one, total equals total plus B of I. Simple. Yeah. So yeah, this is fine. Let me come out of this one entirely. Now, if the total leaves actually exceed the K, then it is impossible accordingly with the criteria of the question, right? So I'll just go with if total is greater than k, it shouldn't exceed, right? So if it exceeds, then it is impossible, and then we have to print -1. They have clearly mentioned in the question. So I'll just give here out dot println of -1. This is fine. And let me give here out dot flush. This is also fine. And then we have to exit from here. So I'll just mention return here. So let me come out of this one entirely. Now let's try to increase leaf counts where possible. This one, where it is possible to reach exactly k, right? So let me go with the iteration again, man. So this one will be int I equals to I less than m. So this one will be plus plus I. So within the for loop, so I'll just go with int now equals. So this one will be mat dot min of a of I minus this one minus this one will be b of I. Yep, this way no. Next we have to go with the k minus total here. K minus total here. So this is fine. Yep. So this is possible increase per level. Now let's do one thing. B of I equals, let's assign b of I equals b of I plus now. Yep. Uh, Next step is total equals total plus now. So this is also fine. The final thing is we have to stop once we get the exact k. Once we have reached exact k, actually exact k leaves, right? So I'll just go with if total, if it is equivalent to the k, then let me give break here. So this is fine. So let me come out of this one entirely. The next step is if even after adjustment leaves is less than k, then it is impossible. Again, we have to print -1. So again, if total here, if, if total less than k again, so let me copy paste the same thing here. Dot println. So the same thing, except that we are checking less than k instead of the greater than k. This one actually same one. So yeah, this is fine, man. Dot print. We are flushing, so this is fine, and we are returning. This is fine. Let me come out of this one entirely. Now, um, one second. So this one we have to consider this one as well, right? So if condition I have already written. So this is fine. One second. One second. I thought I misplaced the brackets. So this is fine. Next, let's move on with the other things. Yeah, the main things. We are left with only one step. Actually, we have to construct and print the edges, nothing but the roads, right? So I'll just go with the table now and let me initialize this one with 1, and also I'll just go with the list. I'll just initialize this one to the 1. Yeah. So now we have to print the total number of cities, right? Nothing but it is saved in the n. I'll just go with the out.println here. Let me pass n here. So this is fine. So we haven't considered n anywhere here. One second. We are going with the n. This n is fine. It was not showing in the suggestions at all. This capital N is fine actually. That is nothing but the maximum possible cities initially. This is fine. Yeah, let's do one thing. Let's move on with the further things, man. Yeah. So let's move on with the iteration part here. So this one will be for int I equals to I less than or equal to m I plus plus. So this is fine. So within the, or let me do one thing instead of, yeah, I'll just go with the. So within the for loop, what shall we do? So I'll just assign temp to this one. Now, so this is also fine. Let me go with the for loop here. In j equals 1, next j less than or equal to a of I. This is also fine. J, let me go with plus plus j. Yep. So this is fine as well. Now after the for loop, so we have to connect the current city to one of the previous level's parent cities. So this one will be out dot println. So this is fine. Uh, plus 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 I'll just include here. We have to leave the space. lst next. I'll just go with the math.max here. Math.max of what we need to consider here. One is j. Along with it, we have to go with a of I minus 1 minus b of I minus 1. So this one will be a of I minus 1 minus b of again I minus 1. So this is fine, I believe. Yep, so this is it. We are just connecting the current city to one of its, this one, previous levels parent children, right? So previous levels parent cities, sorry, not the children. So this is fine. Next step is the final one is we have to update the previous levels start index. Yeah, so I'll just go with, just let me assign this one to the temp actually. Yep. So we are done with the coding part. All we have to do is we have to, this one, what do we call? Flush the output. I'll just give here. You can just close or flush actually. Let me give flush here. This is fine. Yep. So before checking the code with the different inputs, so let me copy paste the signature starter template here. So I'll paste it over here. This is fine. So let me come to the question. Let me copy this one. So this can be of any order, man. Output, it doesn't matter. It is undirected graph as well, and it can be of any order as well. These two things we have to keep in mind. It can be 1, 3, it can be 3, 1, it can be 2, 1, it can be 1, 2. And first 2, 1 might come, first this one 2, 6 might come. It can be of any order. It doesn't matter, right? So let me copy this one. Let me paste it over here. Hey, illegal start of expression. Where? Mm, line number 40. Total double equals. We are checking with what we are doing here. Just let me check here. 1 second. Yeah, we are going with this one. Last level cities are all leaves initially, right? So we're just assigning here this one to the A of M. Run this one again. M has to be capital here. Line number 42 again. Fine. So yeah, we are getting the output, right? So here we are getting the 7 2 2 3 4 3 5 3 6 4 7 4. I hope this part is clear actually. Let's check. So it can have the multiple outputs and the order might differ as well. So let me hit the submit button here. We paste in the submission part and let me hit the submit button. Let's see whether this works or not. Let's wait for some time. Yeah, this is wrong actually. Ordering might differ, but this one order might differ, no doubt. But this has completely. Actually, let's see what's wrong actually. So yeah, what mistake I have done here is this one. This is nothing but the road construction loop, right? So this is nothing but the road construction loop. So within this one, I have to go with a math dot minimum. So this one will maintain this one will balance this one actually, whatever we have written correctly. So we have to go with the min, I believe, not the max actually. So that's the only thing that is wrong, I believe. We are getting the wrong answer. Except that if I give min, if I run this one, 2131. Let's check here 1 second. 21 we have, yeah. 31, yeah. This is undirected graph. Order doesn't matter. And also this one. It can be 1 3 or 3 1. So this is fine. 4253. 4 2 we have 2 4. This is fine. 5 3 we have 3 5. This is also fine. There is 6 3 and 7 4. Mm, 3 we don't have. 7 4 we have. 6 3 6 2 we have. This will be with 3 actually. This one will be this one actually. We can have the multiple answers actually. This is fine. We can have the multiple answers for this particular this thing. If there are multiple answers, print any of them. So this has to work correct this one correctly with what the code that we have written actually accordingly with me. So let's check whether this works correctly or not. Or else the approach, entire approach will be different and it is wrong actually, whatever the approach that we discussed. right? So this has to work accordingly with the question that I have understood in a way, right? So let's check the same thing. So I'll just go with here. Let me give line number this one, question number 746, right? Yeah. And yep. So let me paste this one over here. Let me hit the submit button. So let's wait for some time, man. So this has to work. Let's see. In my opinion, it has to work. Let's see. The only thing is we can have the multiple answers accordingly with the question, and the idea or this one approach with what we went, it is correct actually. In my opinion, it is correct actually. Let's see. Oh yeah, running on the test 23. Yep, this works actually fine. Or else, what would have happened is, so whatever the approach that we went with, that would have been completely wrong, right? So yeah, now we can clearly see here, and the toast it is showing accepted. We don't have to worry. Everything whatever we discussed was correct itself, is correct. Yeah. This is fine. The verdict that we got here is accepted, right? So I hope the solution part is completely clear, man, along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.